Section 17 is entitled Vectors in a Plane. First problem we're going to look at is how you find the component form of a vector, say V. Suppose you're given a vector. The arrowhead is very important. We call that the head, and we call the other end the tail. And if the tail is at 1, 1, and the head is at 6, 3, the vector in vector form, in component form, well, you subtract via the x and the y values, you subtract the head minus the tail. You have 6, 3, 1, 1. And you subtract. 6 minus 1 is 5. 3 minus 1 is 2. And that's the vector in component form. You just subtract the head minus the tail. Subtract the tail from the head. If we were to graph this, when a vector is in component form, the tail is always at 0. 0, 0. That's the origin. X is 5, y is 2. There is your vector. When it comes to vectors, you can move the vectors up and down. You can move them left and right. You can move them both up and left, down and right, any of those orders. You can't change the direction. You cannot rotate it. You cannot make it longer. You cannot make the vector shorter. You can just move it up, down, and left, right. So basically what we did was we brought every point on the vector down 1. And there's that vector. Those two vectors are the same. Looks like I rotated it ever so slightly. I didn't mean to. And now, in the next, we brought every point on the vector 1 to the left. Brought every point on the vector 1 to the left. And we got this vector. The vector in green is that vector down there. That's vector V. Since you can move it, why not move the tail to the origin? Suppose you have vector negative 1/4 is one end, and the other end is, say, 2, 1. 2, 1. And the vector goes that way. That is, that's the head of the vector. And maybe there's the origin. Yx. To find the vector in component form, you put down the head components, the tail, and you subtract them. And if this is vector w, then vector w is equal to negative 1 minus 2, which is negative 3, comma, 4 minus 1 is 3. It's negative 3, 3. Negative 3, 3. And if we were to sketch this, we go out to negative 3, we go up to 3, and there it is. That's the same vector. It looks shorter, but that's because of my scaling. But it's the same vector. I just moved this point to the origin. That every point went like this. Every point went like this. And what I end up with is that vector. Do head minus tail, and you get the vector component. you want to graph it, remember that the tail is at 0, 0, and the head is at this new result you got. Now, some bucks just play head games. They just rename things. Initial point and a terminal point. So I'm going to give you the initial point and the terminal point. We want you to sketch the vector that's given. Actually, since it's a point, suppose it's -1, 2, and 7, 4. Want you to sketch this. Well, x goes all the way out to 7, 4, 5, 6, 7, 8, 7, 6, 4, 2, 1, 2, 3, 4, 5, 6. So I want to sketch the information that you're given. You have 1, 2, that's this point. You have 7, 4, which is way out here. This is the initial point. The terminal point is the end point. Terminal point. Initial point is the tail. Their terminal point is the head. So it's the same problem as before, except they're giving it different names. Initial point, terminal point. Now, if you want to find the component, so part A would say to draw the given information. Part B is to find the vector component. So you do the tail, I meant to say the head, put the tail underneath, and you subtract. 7 minus 1, 4 minus 2. That is the vector component. If we wanted to graph this, we just go out to 6, 2, and we go from the origin. And there it is. I brought every point in that direction. Every point went down and to the left. Initial point means the tail. The terminal point means the head. The vector starts here and it goes in that direction to there. Goes to there. It starts here and it goes there. The next one is scalar multiples. Scalar multiples are easy. If you have a vector R, S, and you have a number in front of scalar, that just means to multiply each component by a. So if you are given the vector 3, 7, and you're asked first to find 4v, 1/3 v, 2/5 v, 1/7 v. Well, for 4v, this is 4 times v. Sometimes when I'll write vectors with parentheses. That's called a typo. I didn't mean to. You put those type of brackets. And 4 times 3 is 12. 4 times 7 is 28. And the vector brackets. 12, 28. Part B, 1/3 v. That is 1/3 of 3, 7. 1/3 times 3 is just 1. 1/3 times 7, well, 1 times 7 is 7 over 3. 7 over 3, and there's that answer. Part C, 2/5 V. 2/5 V. Well, it's 2/5 times V. 3/7. 2/5 times 3 is 6/5. 2/5 times 7 is 14/5. And there's the answer. The last one was 1/7 V. Just 1/7 times each of the components in V. 1/7 times 3, 3/7. 1/7 times 7 is good old 1. And there it is. Straightforward. Know this rule. Walk down the street saying, if I have a scalar, A, and a vector, Rx, Rs, Tu, Wb, whatever you like, Rl, and you multiply this vector by A, you multiply each of the components by A. In 3 dimensions, instead of having 2 numbers for the vector, you'll have 3 numbers. If you multiply that vector by A, you multiply all 3 numbers one by A. Okay, so here it's a different problem. Want us to find A and B. Find A and B. You want V to equal AU plus BV. Plus BW. Really should put bars over the vectors, especially when you have scalars. That way you know which are the vectors and which are the scalars. In textbook, they generally write the vectors in boldface. They tell you that U is 1, 2. They go on to tell us that W is 1, -1. And one of the problems they tell you that V is 2, 1. So they want V to equal AU plus BW. So 2, 1, that's V. V, I'm just basically copying this, but I'm plugging in the information I know. V is equal to A, which they want me to find, times U, which is 1, 2, plus B times W, which is 1, -1. I guess one thing is we should talk about how to add vectors. You add them component-wise. If you have 7, 3, and you want to add to it 2, 5, you add the first components, you get 9, you add the second components. So what I have is 1A, comma 2A, and I'm adding B times 1, which is B. B times -1 is -B. And I add these. A plus B plus A plus B for the first component. And 2A plus -B. Instead of adding a -B, you can just take away B. Now I want this to be 2, 1. That is, I want this to be 2 and that to be 1. And that's what we're going to solve. That's what I want to solve. This should be 2, that should be 1. A plus B should be the number 2, and 2A minus B to be the number 1. Now, coincidentally, if I add these, the b's cancel out. B plus negative b is 0. A plus 2a is 3a, and 2 plus 1 is 3. So now I know a is 1. It's probably easiest to solve b from the first box. A is 1. 1 plus some number, which we're calling b, equals 2. You know 1 plus what equals 2. That's one of the first arithmetic problems we learned. It's 1 plus 1 that equals 2. So b is also 1. And they asked us to find a and b, and I did. This will be 1, 2. This will be 1, negative 1. And when I add them, when I add the two ones, I get 2. And when I add 2 and negative 1, I get 1. Exactly what I was supposed to get. Let's try this one more time with a different vector v. It's a different vector v. Suppose v is negative 3, 7. Well, I want v. I'm basically copying this equation, but I'm plugging in. I know v is negative 3, 7, and this should equal to a times u. I know u, plus b times w, and I know w. And this is going to be a comma 2a. That is going to be the same as before, plus b comma negative b. And when I add these, I add because it said there, I add the first components, get a plus b. I add the second components, adding negative b, the same as just taking away b. And I want this to be negative 3, 7. That is, this should be negative 3, and that should be 7. In fact, I'm going to stop erasing that part if I do any more. This will not change. This will not change. All that changed was vector b. So I want a plus b to be negative 3. And I want 2a minus b to be 7. And again, if I add, I get 3a, that cancels, is equal to 4. So then a is 4/3. And I know that whatever b is, when I add it together, I get 1. b should then be negative 1/3, because that will give me 3 over this sum. This sum would give me 3 over 3, or 1. So a is 4/3, b is negative 1/3. You're going to get a system of equations in two unknowns. And you have to find the unknowns. The unknowns are a and b. And here, I'm going to give you the vector v in component form. V is, say, negative 1 is 3. Negative 1 is 3. And I'm going to give you the terminal end. The terminal of vector v is 4. Okay, it's 7, 9. The question is, what is the head? What does the head equal? Well, what you have to find the head. For right now, we'll call it xy. And you have the terminal. Actually, the terminal is the head, excuse me. The terminal is the head. So we want to find, remember, terminal means head. And using their language, so they want us to find their initial point, which happens to be the tail. Sorry about that. Now what you know, and this is called a formula, you know that the head or the terminal, the head minus the tail equals the component. Well, we know that the head is 7, 9. We don't know what the tail is. Call it X, Y, A, B, Hobby and Mary. Call it what you like. And the component is 7 minus 7, 9. Well, we need to apply the formula. Subtract. 7 minus X should be 7. Okay? The component is 1, 3. The component is 1, 3. I know it's component because of those brackets. The component is 1, negative 1, 3. So 7 minus X should be negative 1. And 9 minus Y should be 3. 9 minus Y should be 3. 7 minus what gives you negative 1? 6, 5, 4, 6, 5, 4, 3, 2, 1, 0, negative 1. 1, 2, 3, 4, 5, 6, 7, 8. I'm getting at it. Don't get it wrong. 7 minus 7 is 0. If you take away 1 more, you get negative 1. 1 more than taking away 7 to take away 8. X should be 8. Okay, and if you take away 7 from both sides, then you may not know that that's negative 8. And if two quantities are equal, you can change their signs. So X is 8. 9 minus some number is 6. 9 minus is 3. 9 minus some number is 3. That number is 6. Y is 6. So the tail is X minus Y. It's 8, 6. Don't write it down as this. They're not the same. This says that. This says a lot of things. This here says the tail's at 0, 0, and the head is at 8, 6. This says the tail is at 8, 6, not the head. When you see those greater than, less than symbols around the numbers, it's telling you that the head is at that point, and the tail is at 0, 0. Okay, let's try another one like this. Suppose they tell you the vector is, so the component is 4, negative 9. I know it's the component because of those strange brackets. They tell you the initial point is 3, 2. Initial point is 3, 2. They want you to find the head. They want you to find the head. And you just have to remember that the head minus the tail gives you the component. And the head, they're asking me for that. So we'll call it X, Y. The tail, which is initial position, is 3, 2. And the component is 4, negative 9. Subtract, subtract. X minus 3, it should be 4. Y minus 2 should be negative 9. Some number, if you take away 2, should give you negative 9. Now, you all know that 7 minus 3 is 4. You start thinking, what minus 3 is 4? 7. If you don't know, X is some number, it's right here. I know if I take away 3. 1, 2, 3. That's x minus 3. I have some number. I take away 3. What do I get? 4. Oh, and that's 5, and that's 6. X is 7. Y is some number. There's y. I know if I take away 2, I end up in negative 9. Remember, 0's to the right of all the negative numbers. This cannot be negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. 0? 0's here? No, it's not. No, it's not. 0's there. That is, this number is negative 8. This number right here is negative 7. Y is negative 7. If you already owe somebody $7, and now you owe them $2 more, yep, you owe them $9. Y is negative 7. And you're just adding or subtracting a couple, or just a few. You can do it like I'm saying. What number plus 4 gives you negative 91? Well, here's some number, x, and I add 4. 1, 2, 3, 4. And I get negative 91. Remember, 0's here. So this can't be negative 92, negative 93, etc. You won't be getting to 0. This number is negative 92, negative 93, negative 94, negative 95. You can solve it by common sense logic. Just use a number line. Understand what the problem is asking you. The magnitude of V. If V is AB, then the magnitude of V denoted like this. Sometimes I'll just put one bar around there. In either case, it means magnitude. Well, you square the first component, you square the second component, you put a cross in between them, plus sign, and you take square root. That's the definition of magnitude. It's the length of the vector. Magnitude means length. So, if V happens to be negative 2, 5, the length, of course, will be the square root of 29. Because the length of V will be negative 2 squared, which is 4, plus 5 squared, which is 25, square root. And 24 plus 25 happens to be 29. And I don't know the square root of any number other than 1 that goes into 29. I know the square root of 2 squared, and 3 squared, and 4 squared, and 5 squared, and 6 squared. None of these numbers go into 29 evenly. So I can't break down the square root of 29. That is the length of the vector V. Okay, you square the first component, you square the second component, you add them up, take square root. And like magic, you have their lengths. Now, sometimes I'll give you a vector like this. 3i plus 4j. That just means 3, 4. The I value goes there, the j value goes there. So if they give it to you, and this is somewhat unusual, but they can, if they give it to you like this, this is equal to the number of i's, comma, the number of j's. So the length of this vector will be 5. 3 squared plus 4 squared, that's 9 plus 16, which is 25. But right now, that equal sign is wrong, because I have to take the square root. And the square root of 25 is 5. I knew 3, 4, 5 worked from Pythagorean triples. 3 squared plus 4 squared is equal to 5 squared. So that's how I knew right away the answer was 5. It's not like I worked out these problems already. When you work out problems beforehand, they're not as energetic as you could be. Suppose we want to find a few things. We want to find the magnitude of u. We want to, here is u over the length of u, and I want the length of that. And how about u plus v divided by the length of u plus v, and then the length of that. And I'll tell you u and v. U is defined as 3/7. V is defined to be 2/1. For the first one, the length of u, that one's straightforward. I square the 3, I square the 7, I add them up. Square root. 3 squared plus 7 squared. It's 58. Nothing goes into 58 other than prime numbers. Okay, so that's the length of u. Now, what about u? Excuse me. What about the second one? Before I can find the length of something, I need to find out the something. What about u divided by the length of u? That is, what about u, which is 3 negative 7, divided by 58, the square root of 58. Now remember, dividing by the square root of 58 is the same as multiplying by the reciprocal. Instead of dividing by the square root of 58, you can multiply by the reciprocal. Now we know how to multiply. I don't care if the number is not friendly. We multiply each component by that value. So I get 3 over the length of 58, comma, 7 over, I meant to say the square root of 58. That's what that equals. But I really want to know what that equals. I want to know what the length of that equals. I want to know the length of that. Now if you think about it, you have a vector of length square root of 58. And you're dividing it by the square root of 58. The length is going to be 1. The length will be 1. The length of this vector will be 1. Because you have this squared. 3 squared divided by the square root of 58 squared, which is 58. Plus 7 squared, which is 49, divided by the square root of 58 squared, which is 58. Square root of that. We're adding, the denominators are the same, keep them the same, add the tops. And that fraction is 1. That fraction is 1. The square root of 1 is 1. If you take a vector and you divide it by its length, then the length of that vector is 1. It's called a unit vector. So vector of size 1, of length 1. So basically, if you have this vector, v, or u, and the length is 5, that is, Here's a number line. Here's 0 and 1 and 2 and 3 and 4 and 5. The unit vector would just be this piece down here. It would just be that. It would just be that little piece. And here's the other 4 pieces. 2, 3, 4, 5. Just that one down there. That would be the unit vector. You took the original vector u and you kept the same angle. This angle, and the same. We didn't change the angle. That is, we didn't rotate it. All we did was make it smaller. And I said earlier, you can make a vector longer or smaller. But it's no longer u. It's now u divided by the length of u. I changed the vector. It's no longer u. It is now called v. That's v. V, by definition, is u over the magnitude of u. It's a different vector. It's a vector of length 1. And let's do the last one. Let us do the last exercise. U plus v divided by the length of u plus v. And we want the length of that. Okay, the answer is going to be 1. If you take any vector, if you add 2 vectors like u and v, you get a single vector. You get a single vector. U plus v is 1 vector. Sometimes you want to think of it as the sum of 2 vectors. Sometimes you don't want to think of it as the sum of 2 vectors. U plus v is some vector. You add 2 vectors, you get another vector. Call that other vector w. U plus v is w. So the length of u plus v, well, that's the length of w. I want the length of that. The answer will be 1. But we can work it out. Not a big deal. First, let's find out what u plus v is. U plus v is 5/8. That's u plus v. Okay, so we have u plus v. What is the length of u plus v? Square the 5, square the 8, add them up, square root. 25 plus 64, which, if I'm not mistaken, is 89. The square root of 89. That is the length. So let's figure out what that is. U plus v divided by the length of u plus v. Well, it's u plus v, which is 5/8, divided by the length, 89. That is, it's 5 divided by the square root of 89, comma, 8 divided by the square root of 89. But we don't really want u plus v over the length of u plus v. We want the length of that. We want the length of that. We want the length of that. So it becomes 5 squared over the square root of 89 squared plus 8 squared divided by the square root of 89 squared, which is 89. And 5 squared is 25. The square root of that. But since the denominators are the same, I can just add the numerators and keep that same denominator. And once again, I get the square root of 1, which is 1. Depending upon your teacher and what he or she wants you to show. If somebody asks you what this is, you should just say 1. At least know it's 1. Make sure in the end you get 1. Any vector, I don't care what they call it, if they divide it by the length of that vector, and then they ask you, what's the length of that result? It's 1. It's 1. And we did 2 examples, we worked it out, and we got 1. We'll actually do it in general. Suppose u is a comma b. So then the length of u will be a squared plus b squared square root. So u divided by the length of u would be the a gets divided by this, comma, and the b also gets divided by that. That's the vector u divided by the length of u. But I don't want that. I told you I want the length of that. So I take the length of both sides. So I square the first component plus, and then I square the second component. B squared over a squared plus b squared. Then I take the square root. If the bottoms are the same, in addition, the denominators are the same, keep them. In this case, add the numerators. That's 1 under the radical sign. The square root of 1 is 1. It's always going to be true. Okay, I had a teacher who once gave us v and asked for the length, divide by the length of v, find the length of that. And gave us w divided by the length of w and asked for the length of that. And then gave us the vectors x and asked us to calculate this length. And gave us the vector y. I think he was in a bad mood. Divided by the length of y and asked us for the length of that. Now, one would have to do this 4 times like I did a few moments ago, but I wasn't going to do that 4 times. I did this. I literally wrote this on the paper, and then I said, these all equal 1. They all equal 1. I only had to do this mess 1 time, not 4 times. There was no level of difficulty or too long to write e equals 1. So that was pretty easy for me to do. So I only did this 1 time. In general, you know, like I said, the teacher told us what v was. V was 3, 1. W was negative 2, 5. And the teacher also told us what vector x and what the components of vector x, components of vector y. But I didn't do what he wanted, and his hands were tied. He gave me full credit. Somebody asks you to keep doing the same exact problem over and over with different numbers. Well, try to come up with a formula. So you can just derive the formula 1 time and then just plug in the values. In this case, 1. Now, there's something called the triangle inequality. The triangle inequality says that the length of vector u plus v will be less than or possibly equal to the length of u plus the length of v. And a lot of times you're asked to verify that. Suppose you have u is equal to 2, 1, and v is equal to 3, negative 1. So verify that this is true. Well, u plus v would be 5, 0. Now if you think about it, 5, 0 is this vector right here. It's horizontal. It's actually on the x-axis. You know the length is 5. If you want to use the formula, go for it. But the length is 5. You get 5 squared plus 0 squared square root 25 plus 0, 25. The square root of that is 5. So we now know that the left-hand side is 5. And we didn't have to do any of that work to figure out it was 5. Now what is the length of u? Well, the length of u is 2 squared plus 1 squared, which is the square root of 4 plus 1, which is the square root of 5. That is the square root of 5. The length of v, the length of u equals that. Equal signs have to be valid. The length of v is 3 squared plus negative 1 squared square root to the square root of 10. 3 squared plus negative 1 squared, 10. So the question is it true? Is 5 less than the square root of 5 plus the square root of 10? Is that true? Well, I know that the square root of 5 is in between the square root of 4 and the square root of 9. That is, it's between 2 and 3. And the square root of 10 is less than the square root of 16, which is 4, and it's bigger than the square root of 9, which is 3. So, 2 plus 3 is 5. I add the left sides, and I add the middles. The square root of 5 plus the square root of 10. And this on top is true. The square root of 5 is less than 5, the square root of 5 plus the square root of 10. Now, why is this somewhat obvious? Why is this going to be obvious? Okay. If this is u, if that's u, and that's v, so I move them so they touch one another. This here will be u plus v. So you have the lengths of v and the lengths of u. That's the length of u, that's the length of v. And here's the length of the sum. This is smaller than the sum. If this is 3 and this is 4, and 3, this can't be more than 7. I mean, if I opened up the angle, if I made the angle bigger, that doesn't look much bigger, is it? If I kept making the angle bigger and bigger, this angle in between them, if I make it bigger and bigger, it's still 4 and 3. I make it even bigger, almost a straight line. This is 4 and 3. Well, if I opened it up completely straight, then this would be 3 and this would be 4, and then the length between them will be exactly 7. That length is less than 7. This is even smaller than 7. The beginning one is the smallest of all of them compared to 7. Okay, you'll never get more than the sum. This length of one vector plus the length of another vector is always going to be at least as big as, it will be equal to or bigger than the length of the sum. What this is telling you, if you live here, if you live at point A, and you know your friend, person B, lives 10 miles from you, and your friend C lives 12 miles from you, you can say without a doubt in your mind that B and C cannot be more than 22 miles away. It cannot be more than 22 miles away. In fact, if you take the difference, you can find the least. If you do 12 minus 10, you can find the least distance they can be. 12 minus 10. They're between 2 and 22 miles apart. B and C are between 2 and 22 miles apart. How can they be 2 miles apart? Well, if A lives here and B is here, but to go from A to C, you find the same route to B. That is, they're collinear. They lie on the same line. If this is 10 and that's 12, well then that must be 2. You're not going to get smaller than 2. So, your triangle inequality guarantees you that the distance will always be less than or equal to the sum. The distance between person B and person C will be less than the distance from A to B plus A to C. And that's good to know in everyday life. I mean, you have an idea about, you live here, and other friend lives here, and the third friend lives here. And you know that you're 2 miles apart, and this person is 3 miles apart. You now know that they're no more than 5 miles apart, 5 or less. In fact, if you add them up, you get the max. If you subtract them, you get the min. You know that your 2 friends, B and C, Betsy and Claudia, are between 1 and 5 miles apart. If you're 2 miles from Claudia and 3 miles from Betsy. Right. So, I want you to find the vector v such that vector v has length 4 and it's in the same direction as vector u. In other words, if here is vector u, that's vector u. Vector v is going to be part of vector u, exactly vector u, or bigger than vector u. If vector u happens to be less than 4, if the magnitude of v is less than 4, then v would be longer. That would be v. If vector u was bigger than 4, well then vector u would be longer. But they're both in the same exact direction. Okay, they're in the same direction, except the length is 4. Here is your school. That's your school. And here's the route that, or road that goes from your school. And it goes way out to here. It goes out to this point here, and then it's a dead end. And there's other roads coming off. But for whatever reason, you want to live on that main road. You want to live on that main road. But don't ask me why. You want to drive exactly 4 miles, not 4.5 miles, not 2 miles, 4 miles. Okay, that's what the problem is asking. This is the vector u. That's the vectors 3, 1. And the tail happens to be by the school. And the road ends right at 3, 1. It's dead end. Stops. So you want to live 4 miles on that road. That's exactly what this is asking. In everyday language, at least. So, we want to find the vector, the length of vector u, and scale it so that length is 4. The length of u is 3 squared plus 1 squared. 9 plus 1 is 10. It's the square root of 10. But I want it to be 4. So the square root of 10 times what? I'll call it y, is equal to 4. Divide by the square root of 10. A lot of students can solve a linear equation like that. But you have to get mathematically mature enough to write down your own. Square root of 10 times what is 4? The answer is y is equal to 4 over square root of 10. And I don't like radicals in the bottom. So I multiply by radical 10 over radical 10. The top gives me 4 radical 10. The bottom gives me 10. 2 goes into 4 2 times and into 10 5 times. So it's 2 square root of 10 over 5. If I take u, if I take vector u, and I multiply it by 2 times the square root of 10 over 5, I will now have a vector that's exactly of length u. And it's in the same direction as u. When you multiply your vector by a positive scalar, it maintains the same direction. Either makes it longer or shorter. If you multiply by a negative number, then it changes the direction to opposite. If vector u goes that way, a vector going in the opposite direction, that means we multiplied it by a negative scalar. But I didn't do that here. So multiplied by 3, you get 6 radical 10 over 5, comma, times any number by 1, get back that number. Here is a vector whose length is 4 and is in the same direction as u. I just figured out what I had to multiply the square root of 10 by, the length of u, to get v, the length of v, which is 4. So that's v. What do you multiply square root of 10 by to get 4? Divide by square root of 10 and you get your answer. Okay, suppose u is the square root of 3 comma 3, and you want the length of v to be 2. You want to find a vector v that goes in the same direction as u, but length is just 2. Well, the length of u, that's the first thing you need to find out. It's the square root of 3 squared plus 3 squared square root. The square root of 3 plus 9, the square root of 12, which is the square root of 4 times the square root of 3. That is absolutely how I write the square root of 4. So that's the length of u. Now, what do you do to this to get 2? Well, here's an easy answer. You divide by square root of 3. 2 square root of 3 times y gives you 2. You divide by this 2 square root of 3, you divide by 2 square root of 3. You bring that to cancel. Coincidentally, that cancels. You get 1 over square root of 3. That is what you multiply v by. I meant to say u. So u, vector v, should be 1 over square root of 3 times vector u. 1 over square root of 3 times u. U is square root of 3, comma 3. Now, I'm going to think of 3 as square root of 3 times square root of 3. That way, the division is easy. Multiplying by 1 over square root of 3 is the same as dividing by square root of 3. Square root of 3 divided by square root of 3 is 1. One of these square root of 3's cancel, and you're left with the other square root of 3. And there is your vector v. If you hated the way I did the arithmetic, I mean, do it however you like, but you'll get the same answer. 1 over square root of 3 times the first component, that's 1, because the square root of 3 is canceled, and you get 1. So this is 1, comma. 1 over the square root of 3 times 3. Means 3, I'm just going to do it again. That's 3. This cancels out. You get 1 times square root of 3. I guess in the bottom left, I'll do it the third way. 1 over square root of 3 times 3. This is 3 over the square root of 3. But we don't like radicals in the bottom. So you multiply by 1. Square root of 3 over square root of 3. The numerator is 3 times the square root of 3. The bottom is square root of 3 times square root of 3, which is 3. The 3's cancel out, and you get the square root of 3. So however you do it, get the square root of 3. That is vector v. That is vector v. Find out what you multiply the lengths of u by. What do you multiply the lengths of u by to get the lengths of v? Whatever that answer is, that's what you multiply u by. The answer was you multiply by 1 over square root of 3. If I take the lengths of u and I multiply by 1 over square root of 3, I get 2, which is what I wanted. So that's what I multiplied u by. I took u and I multiplied it by 1 over square root of 3. And I said, that's v. That's my v. So you walk down the street and you think, well, I'm given a vector u. They give it to me. They give me the components. And they want me to find the length, they want me to find a vector v that's in the same direction as u, but they tell me what the lengths must be. What do I do? And in other words, when you go in for an exam, you have to know what type of problems will be on the test and how you're going to handle it. Spend half your time just thinking about what do you do when you have this type of problem. Okay? Even if you're real good at the mechanics, if you don't know what the steps are, you won't know to do these steps that you know how to do so well. In other words, if you know how to add, make believe you're much younger, etc. You know how to add. You're really good at adding. And you're really good at subtracting, etc. You're like the best. But you don't ever remember that that symbol means plus and that symbol means subtract. So if somebody gives you 7 plus 8 on the test, or 17 plus 8 on the test, and you're like, oh my, is it 25 or is it 9? I never remember what that symbol is. Okay? It's because you didn't study, you didn't sit down and learn that rule, that step. When I see that symbol, that means add. And of course, I trivialized the point I'm making by using addition. But it's still the case. Suppose I give you a vector, I give you the length of a vector, and I tell you the angle that it makes with the positive x-axis. How many degrees off the positive x-axis. And the instructions are to find vector v. Okay, that is, what is v equal? What goes inside that? What's the components for v? Well, let's draw our picture. Here is the x-axis, here's the y-axis, and you're 0 degrees off the x-axis. If you were 1 degree, it would go like this. And I made sure the length was 3. If it was 2 degrees, it would be bigger. If it was 50 degrees, it would be a bigger angle. But we're 0 degrees off the x-axis. That is, we're on the x-axis. And we go out to 3. There is your vector. And in component form, you just need to say where the head is. I mean, it's starting at the origin, and you just have to define the head. It's 3, 0. And the problem is done. The problem is done. Simple one. Simple because they're lying on the x-axis. If the angle was 180 degrees, then it would have been on the left side of the x-axis. What if the length of V is 1 and it makes a 45-degree angle? Excuse me, the angle is 45 degrees off the positive x-axis. Okay, so 45 degrees is up to there. That is 45 degrees. Now we want the length to be 1. Okay. Well, we know ordinarily this is 1, 1, square root of 2. Because it's a 45, 45, 90 degree right triangle. And right now, I'm saying that's V. Right now, I'm saying that's V, and the point would be 1, 1. But it's not V, because the length is wrong. The length is wrong. The length is 2. Excuse me. The length is square root of 2. Well, what do you do to square root of 2 to get 1? Answer. You divide by square root of 2. You do that to all 3 sides. You divide the square root of 2 by 2, that gives you 1. You divide the 1 by square root of 2, it gives you that. You divide the other 1 by square root of 2, it gives you that. Here is a 45-degree angle off the positive x-axis, and the length of this vector is 1. The length of that vector is 1. If only I knew that tail end. But I do. That's the x value, and that's the y value. Here it is. You have to scale it. You have to scale. What do you do to square root of 2 to get 1? What do you multiply square root of 2 by? Call it x. What do you multiply square root of 2 by to get 1? Divide by square root of 2 and you get that answer. That number that you multiply square root of 2 by to get 1 is 1 over square root of 2. It is easier, I felt, to just say, oh, I'll divide by square root of 2 to get 1. So I do that to the other 2 sides as well. The first one was very simple. We did another one which was harder. Let's do a second one that's harder. Harder means it's not on the x-axis. Suppose I tell you the length of V must be 2, and the angle is, say, 150 degrees off the positive x-axis. Okay? 90 degrees and then 60 more. What that tells me is that that's 30 degrees. It also tells me to draw a right triangle. Now I know everything about a 30, 60, 90 right triangle. 1, 2, square root of 3. This is going up, so it's positive. This is going to the left, so it's negative. That means I know this point. It's 1, excuse me, it's negative square root of 3, 1. It's x, comma, y. The nice thing is the length is 2. Exactly what they wanted. But let's change it. want 3. I want 3. Don't want 2. I don't like 2 anymore. What do you multiply 2 by to get 3? 2 times what gives you 3? The answer is 1.5. So basically, I just play with the scale. Make it longer. It's still the same 30, 60, 90 right triangle. I multiply the 2 by the 3 halves, and yep, I get my 3. I multiply the x value by 3 over 2, and I get negative 3 square root of 3 over 2. Negative 3 square root of 3 over 2, and I multiply the 1 by my 3 over 2, and of course I'll get 3 over 2. So this length, this vector, that's 150 degrees off the positive x-axis, you know what? It has a length of 3. This vector right here has a length of 3. And I know that terminal point. It's at negative 3 square root of 3 over 2, comma, 3 over 2. That's my vector v. 150 degrees off the positive x-axis. It has a length of 3. Okay. These columns should be fun. They shouldn't be brutal. But there's some things you have to know. Like you have to know the special 30, 60, 90 right triangles. Okay, you have to know the rules to play the game. If you don't know the rules, the game is very hard to play. Okay, so let's do one more. This one might be fun. The length of V should be 1. And the angle is 3.5 degrees. Okay, so we have 3.5 degrees. Basically, what you should do is find the tangent of 3.5. Okay, actually, let's do that. Let's see if either of my calculators have the battery in them. Okay, so we want to make sure we are in radians. Make sure we're in radians, which I'm actually not in. And then we compute the tangent of 3.5. Tangent, it's got to be there somewhere. The tangent of 3, oh, actually, excuse me, they said it was in degrees. That's real simple to make a mistake. It doesn't mean you don't know it, it just means you were careless. You want to calculate the tangent of 3.5 degrees. According to my calculator, we get approximately 0.0612. So that's approximately what I get. Over 1. That is, this is 0.0612, and this is 1. But the hypotenuse is going to be more than 1, because the hypotenuse is the longest side. Well, what I do know is that the hypotenuse right now is 1 squared plus 0.0612 1/2 squared square root. So I had the exact value, well, I had a better approximation in my calculator. So you should use that approximation. And like I said, you want to square that. You want to square that. Then you want to add 1. And then you want to take that answer, because 1 squared is 1. Then you want to take that answer and raise it to take the square root of that. According to my calculator, what you get is 1.001869. The problem is, that isn't 1. That isn't 1. So the question is, what do you multiply this number by to get 1? Well, if you think about it, I'm just doing it a different way now to give you alternatives. If you divide by that same number, you get 1, and then you multiply by 1. That is, the number, this will give you 1. The number in here is what you multiply all the sides by. That is, you divide by 1.001869, you divide by 1.001869, you divide that number by itself, and it gets 1. Okay? Other than doing the division, which a calculator can do pretty easily, other than doing that division, I now know this terminal point. This terminal point is x, 1 over 1.001869. Work it out, you can do it, comma, the y value, 0.0612 divided by this number. And there's yet another problem solved. The angle is 3.5 degrees, and if the length is to be 1, you should use those. That's the component. The terminal end should be at that point. Alright, that finishes the section entitled Vectors in the Plane.